Hi, seventh graders. We are going to talk a little bit about experimental probability today. Quick review of probability. Probability is the chance or the likelihood of an event happening. You can express probability as a fraction, a decimal, or a percent between 0 and 1 whole. That would be like from 0% to 100%. And then depending on what the probability of an event is, you can also describe the likelihood of that event happening. So, for example, if you have a probability of 0 or 0%, the likelihood of that event happening would be impossible. If you have a probability of 1 whole or like 100%, then that event would be more certain. And then if you have a probability of like 1/2 or 50%, that would be neither likely nor unlikely. So what we're going to do is we're going to talk a little bit about experimental probability today. And so experimental probability is what does happen. And this means like you have data. Okay, so it's not just like what you think might happen, but you've actually surveyed a group of students and you have your data, or you've actually spun a spinner, or you've rolled a die and you have data to look at, okay? And so here we're going to be using our experimental probability and we're going to be making some predictions using that. So here it says, a teacher asked his students about their favorite season. The results are shown in the table. So I can see that 5 students chose spring, 8 students chose summer, 4 chose fall, and 3 chose winter. So I'm looking right over here. And the very first thing that I'm going to want to do is I'm going to actually want to figure out my total number of students that were surveyed. So I have the breakdown of it, but now I need to add these all up. And so when I add these up, I'm actually going to get 20 students, okay? So 20 students were surveyed, and then that's the breakdown of their favorite seasons, okay? So I'm going to first be writing out my experimental probability of an event, and then we're going to use that to make a prediction. So number 1 says, out of 50 students, how many would you predict would choose fall as their favorite season? So the first thing I'm going to do is I'm actually going to look at my experimental probability, my data I have of a student choosing fall. So right now 4 out of the 20 students have chosen fall. And because I know this fraction can be simplified, I'm going to go ahead and simplify it. And so 4 and 20 have a common factor of 4. And so that fraction simplifies to 1/5. So this means 1 out of every 5 students chose fall as their favorite season. So now what I'm going to do is I'm going to use that information, that experimental probability, to make a prediction of how many students out of 50 would choose fall, okay? So here the 1 is representing my students that chose fall, the 5 would be my total, and so if I'm going to survey 50 students, 50 is a total number, and then I would be figuring out the number of students that are going to choose fall. So we're setting up a proportion, we're looking for an equivalent ratio. And then once we have our proportion set up, remember you can solve proportions in a variety of ways. So some of you might look at this proportion and some of you might notice that 5 times 10 is going to give you 50. So 1 times 10 would give you 10. So then we could predict that 10 students would choose fall as their favorite their favorite season. Another way that we could solve this would be using our cross products. So 1 times 50 is going to equal the same thing as 5 times x. So 50 is equal to 5 times something, and we can divide by 5 to get 10 as our answer there. Okay. Our next one, number 2, out of 80 students, how many would you predict would choose summer as their favorite season? So again, we're going to look back at our experimental probability of a student choosing summer. And so when I look at this, I see that 8 students out of 20 chose summer. So I have an experimental probability is out of every 20 students, 8 students would choose summer, okay? And I can use that probability to make a prediction. Again, we're just making a prediction. It's not for sure gonna happen, but we're just approximating. So I could do a couple things. I could simplify that fraction. In this particular case, it might almost be easier for me to use that fraction as it is, okay? Because I'm gonna then try to predict out of 80 students, how many would I predict to choose summer? And so if I keep the probability as the 8/20ths, even though it technically can be simplified, it's pretty easy for me right now to see that, oh, well, 20 times 4 will give me 80. And so if I take 8 times 4, that will tell me how many students we could predict would choose summer as their favorite season. So that means about 32 students should choose summer if we surveyed 80. And then, let's see, we're gonna skip number 3 right now. Number 3 is gonna be the same idea. We're gonna look at number 4. So out of 164 students, how many would you predict would choose spring as their favorite season? So same idea, I'm gonna look, I have 5 out of 20 that chose spring as their favorite season. And I'm gonna figure out of 164 students, how many would choose spring. And so, again, a variety of ways you could solve this proportion. You could use your cross products, you could look for a relationship. You could also use a vertical relationship. So 5 times 4 is gonna give us 20. So we could ask ourselves, what times 4 is gonna give us 164? And so depending on, well, actually it doesn't matter whichever way you solve it. So whether you look for that mental math relationship or you use your cross products, whichever way you solve it, you should end up getting 41 on this one. So X would equal 41 students. Five through 7 are very similar. So again, the first thing that you're gonna wanna do, we have a survey, we have our data. We're gonna wanna figure out our total for the data first, okay? And then come up with those experimental probabilities and set up a proportion to help us solve them. We're gonna look at a few more just to kind of get the idea of how we can come up with experimental probability. So on these ones, these are more just like word problems. And again, the experimental probability is what actually happened. It's your data of what already happened. So number 8, a sparkling water company puts winning codes inside the lids of some of their bottles. Olivia found 3 winning codes in 32 bottles. What is the experimental probability of finding a winning code? So here, all we want to do is we just want that experimental probability. So out of 32 trials or 32 bottles, 3 of them had the winning code. And so this would be our experimental probability. Okay, and then from here, we could use that information to make a prediction if we wanted to. Right now, this is just asking for the experimental probability. And that can't be simplified any further, so that would be our final answer. Number 9, a basketball player is practicing making free throws. The player makes 24 free throws in 40 attempts. So we're gonna look, they had 40 trials, 24, they made the 24 free throws out of the 40. And so here's our experimental probability. Now this one can actually be simplified. So when I look at 24 and 40, I see that 8 is a common factor of both of them. 24 divided by 8 will be 3, and 40 divided by 8 will be 5. So this simplifies to 3/5, which if I wanted to also convert to a percent would be about 60% of the free throws. They made about 60% of their free throws. Number 11, a mechanic inspects 25 cars. The mechanic finds that 17 of the cars passed the inspection without any additional work needed. What's the experimental probability of a car passing inspection? Again, 25 cars were inspected, 17 out of the 25 had passed the inspection, okay? And so this would be our experimental probability of the cars passing inspection. So experimental probability is what does happen. It's going to be the data you already have, and you're going to use that to express your probability as a fraction, a decimal, or a percent. Have a wonderful day.